taken, and this type that we're going to be going over is type D. Question 2 wants us to convert 27 base 10 to another number in base 3. So in order to do this, we have to take 27 and divide it by 3 to get an answer. Take that answer and divide it by 3, get an answer, and do it over and over again. We're going to be paying attention to the remainders and using that to get our new number. So starting off, we take 27 divided by 3, which is 9, so we get a remainder of 0, and we write down 0 over here. Then we take that answer that we got, which is 9, and divide it by 3, which is 3. We have a remainder of 0, and we write that over here. 3 divided by 3 is 1, with a remainder of 0. I got this 3 from up here. It was the answer from our previous division problem. Again, we have a remainder of 0. So this time, we're taking 1, because that's the answer that we got. 3 into 1 does not happen. So it would be 0, and you'd be left with a remainder of 1. So you put down that 1. To get your final answer, you would simply look up, go up the column that you just wrote. So it's going to be 1, 0, 0, 0, base 3. And that's your answer. Question 4 wants us to evaluate 1.25 times 0.025 over 0.05 correct to 1 decimal place. So the first thing that you need to do is simplify what all of these decimals mean. You could go and do the math with the decimals, but there's an easier way to do it. 1.25 is the same as saying 125 out of 100. And 0.025 is the same as saying 25 out of 1,000. Literally, this is read as 25 thousandths. And over here, this would be 5 out of 100 because it goes tenths, hundredths, 500ths. So now that you have that, you can set up the problem to use the same numbers as before, but this time in the new ways that you've written them with the fractions. So we have this form, and then to simplify further, we can work with this section right here. Remember that when you divide a fraction, you can multiply by its reciprocal. So here we have multiplication, and we're multiplying by the reciprocal, which means I flipped this. Instead of 5 over 100, it's now 100 over 5. Once you have this set up, you can just start simplifying. So this 100 will cancel with this 100 up here. Each of them cancel to 1. This 5 can go into this 25. So the 5 cancels to 1 and the 25 cancels to 5. Now you're left with 125 times 5 over 1,000. So that came from this, this, and this. Everything else had canceled to 1. All you're left to do is some simple math of 125 times 5, which is 625, over 1,000, which is just 625 thousandths. So you can put in your decimal, and it's 0.625. But remember, they asked for 1 decimal place. So you simplify it down to just 0.6. Question 5 asks us to calculate the time taken for 3,000 Naira to earn 600 Naira if invested at 8% simple interest. So the way that I've solved this is I've said to first take the equation for simple interest. So you have here your principal, your rate, time divided by 100, and that will give you your interest. And so let's keep in mind what they're asking here. They said calculate the time taken. And so what you would want to do is you would want to solve for time. So that's what I've done in steps 2 and 3 here. I've simply isolated this part. So first I took and multiplied by the denominator on both sides, so that I had 100 times the interest gives me the principal times rate times time. And then I divided by principal and rate to get time on one side. I had time is equal to 100 times the interest divided by principal times rate. So your next step would be to plug in the numbers that they already gave you. So you have 100 as a stand-in from here, 600. You are earning the 600 as your interest. That is your interest. And then at the bottom is the rate. This is 8% is the rate, and the 3,000 is the principal. So you're putting in 3,000 at a rate of 8%, and you want to make an interest of 600. The time taken will be what you get when you work all of this out. So all you have to do is cancel these zeros so that you're left with 100 times 6 over 30 times 8. And you can simplify the 30 and the 6. So the 6 reduces to 1 and 30 to 5. So now you just have 100 over 5 times 8, which is 100 over 40. Again, you cancel zeros, and you're left with 10 over 4, which is the same as 5 halves, which is the same as saying 2.5 years, which is your option C. Question 6 wants us to simplify, and I've rewritten what they had here, so it's a little clearer to see. So it's 3 to the negative 5n over 9 to the 1 minus n, multiplied by 27 to the n plus 1. So what you're going to do is you're first going to take this base number and this base number and convert it into one where it's base 3. So 9 is the same as saying 3 squared. So now you have 3 squared to the 1 minus n. So nothing has changed from here to here except the notation. I just changed 9 to 3 squared. I do the same thing with the 27. 27 is equal to 3 cubed. So you're going to take 3 cubed to the n plus 1. But since these are exponents, it's squared times 1 minus n. So the previous exponent that was already there, this 1 minus n, is now being multiplied by the 2. And this n plus 1 is being multiplied by 3. So, as you can see here, I expanded the 3. So I said 3 times n and 3 times 1. So now this is 3 to the 3n plus 3. Over here, I've also done the same thing with this part. I said 3 to the 2 minus 2n. So why is this on the bottom now? This negative over here on the negative 5n means that it's just on the bottom. So now I have 3 to the 5n times 3 to the 2 minus 2n, and that's in a fraction underneath 1. So 1 over this quantity times 3 to the n plus 3. Okay, I promise things will start to get a little clearer now. So that means that I can just take this top part and plop it right over this, because 1 times this whole number over here will just be this number. So now I have this 3 to the 3n plus 3 over 3 to the 5n times 3 to the 2 minus 2n. So now what I can do is say these all are a base of 3. So that means I can combine all of these exponents in a way. So now I have this top part, 3 minus 3n plus 3, and I left it as it was. And then I said subtract from that, you're subtracting this quantity. So you can add these two because they are right next to each other. This is being multiplied by this, and when that happens, you can add the exponents. So I've added them, but since they're on the bottom half of the fraction, I have to subtract them from the top half of the fraction. So simplifying even further, I find I have a 3n minus 5n, and then plus 2n. That gives me 0. And 3 minus 2 is 1. So I have 3 to the 1 power, which means that my answer is just 3. Which is your option over here for B. Question 7 tells us if log base 10 of 4 is equal to 0.6021, evaluate log base 10 of 4 to the 1/3 power. So all you have to do is recognize this form. And you also have to know what to do with this exponent. So essentially, just remember that log base 10 of 4 is equal to this set of decimals. So over here, we have 1/3 times log base 10 of 4. How did I get there? I took this exponent and I put it over here. Because by the rules of exponents, you can do that with log. So now I have 1/3 times the log base 10 of 4. So the next step would be to recognize this part as this. That means I can replace it with this. So that's what I did. Now I said 1/3 times 0.6021. So then what I did from there was I said that multiplying by this fraction is the same as dividing by 3. So I did some long division, and I found that 0.6021 divided by 3 is 0.2007, which matches your option for answer B. Question 8 wants us to simplify, and it has the square root of 5 multiplied by the square root of 147 minus the square root of 12 over the square root of 15. So the way that we want to work this out is we want to start breaking things up. So this 147 is the product of 49 and 3. Why did I choose 49 and 3? Well, because 49 is a number that has a square root easily. It's 7. And so you have to play around with numbers in your head to find out what you want to break these into. Let's look at the square root of 5. There's nothing you can break that into. It's just going to be 1 times 5, and you're left with 5, and so you're just going to leave the square root of 5 alone for now. Over here with the square root of 12, it's easy to break it up into 3 times 4, because 4 has a square root that can be taken easily. I didn't choose 2 and 6 because neither 2 or 6 can be taken the square root of. So here we have this. So like I said, I broke these up. So 147 is now 49 times 3. 12 is now 3 times 4. And I noticed that I left them in their square root symbols. So the next thing I'm going to do is, oh, and I did the same thing with 15. Here's 15, it's now 5 times 3. So I broke apart this, and I made it into this. Because remember that when you're taking the square root of a product, you can split apart that product. You can say that that's equal to the square root of 5 times the square root of 3. That's perfectly okay. Once I did that, I could cancel these two. So now I'm done with the square root of 5, and it's a little bit easier. So then I did the same thing with this and this. I broke them apart. So now I have 49, the square root of 49 times the square root of 3, and that's a quantity. And I'm subtracting the square root of 3 times the square root of 4. And again, it's over 3, over the square root of 3. So that means that I can pull out the square root of 3 because it's common to all of these. This quantity, and this single number down here. So once I took them out, it went something like this. I took the square root of 49 times the square root of 3. So the square root of 49 comes easily, so that's 7. And the square root of 3 I can't take easily, so I leave it as is. Same thing over here. The square root of 3 will stay, but the square root of 4 is 2. And it's still over the square root of 3. So that's how that ends up canceling as I did in this step here. Now I'm left with 7 minus 2, which is 5, which is your option for answer C. Question 9 says P, Q, and R are subsets of the universal set U. The Venn diagram showing the relationship which has P intersection Q union R is, and so what you want to do is first remember what intersection and union means. So when you have a union, which could be called a marriage, or you will be taking everything that P and Q have. And what that means is, say I have two sets, and P has flowers and a vase, and Q has a vase and a TV. My final set will consist of flowers, two vases, and a TV, because that's a union. However, if it's an intersection, then you will only be taking the similarities. That means only what P and Q have in common. So now instead of having two vases and flowers and a TV, I'll just have the vase. Well, technically the two vases, because that's what they have in common. Where P and Q have an intersection, and that is combined with the union of R. So P and Q intersect here. And you also want to include what R has. And you can include everything of R. So that's why this circle is covered. The R circle is completely covered, because you're including everything of R and only where P and Q intersect, which is there. So that means that your option is C. So 10 is a question about sets, and it says if p is equal to x when x is odd, and negative 1 is less than x is less than or equal to 20, and q is equal to y, where y is prime and y is in between negative 2 and 25, find p intersection q. So I've rewritten what they said. So here I have x is odd, and then it has to be somewhere between negative 1 and 20. So that means that your options are negative 1, 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. These are all the odd numbers that fit the criteria in here. Okay, and then except for negative 1, because it is not equal to. That one does not go in there. Anyway, next they said where y is prime, anywhere between negative 2 and 25. So your options are negative 2, again, that shouldn't be in there because it's not equal to. But anyway, 1, 2, 3, 5, 7, 11, 13, 17, 19, and 23. And so I've tried to highlight in red the numbers that are common between these two sets. Those numbers are going to be 3, 5, 7, 11, 13, 17, 19. And so that's going to be your option A.